Right, so the next chapter of our bivariate data unit is on 7F. And in this chapter, we're focusing on using the least square line to model a linear association. Now, this basically just means I'm creating a line in our scatter plot. Now, remember in the previous lesson, we were looking into how to interpret R and R squared. Remember that R value talks about the strength, the form, and the direction of a scatter plot, and that's a numerical value. It's basically measuring the association between both variables. The higher the number, the greater the association, meaning on a scatter plot, if it's a really high number like this, so it'll look something like this. Okay, where you can see that EV and RV have some sort of direct connection or relationship with each other, and the graph will look somewhat like that. Okay, and then your R squared talks about what percentage of the EV actually affects the RV. So again, if it looks like it's a high R squared value, you'll see a graph that looks like this. Okay, where you can see that this EV will directly affect what happens to the RV. So as EV increases, so does RV. And it could also be the other way around. Okay, where if it's a negative like this, so as EV increases, RV might decrease. Okay, but basically you'll see that it's got a really strong sort of strength, and it's obviously linear, and the direction is very obvious as well. Okay, we use when it comes to R squared. Okay, we use the R value. R squared value can be obtained using the same way as the R value as well on your CAS. And we use percentage, by the way, for the R squared when we interpret. Okay, so for chapter 7F, we're looking at how we actually derive a line from a bunch of dots, or a bunch of in the scatter plot. So we use what we call a least square method when we do this. Okay, it's basically a strategy where we fit the line in a scatter plot using a formula in a sense, but we won't really be using this to actually draw because the CAS will do it for us. But this lesson will focus on understanding how a residual is used to actually draw the line. Okay, so rather than fitting a line by eye, which in year 10 you would have called it line of best fit, which will give different results for everybody, we actually use this method to actually draw the line. But you won't be doing much of it in year 11 because your CAS will do it for you, but we'll learn how to do, at the very least, calculating residuals. So a residual is basically the space, okay? The residual is basically the space between the line and where the scatter plot dots are. Okay, so residual is basically the space between where the line is, or a value on the line, and a point on a scatter plot. So for example, there is a residual, that's a residual, that's a residual, that's a residual. So it's looking at this space. Okay, these spaces. Now there's an actual way to calculate the residual, and it's this formula. It's the actual value, okay, on the scatter plot, okay, whatever it might be, take away the predicted value on the line. So for example, if you look at the scatter plot here, actual value of 4, so we're looking at the y sort of points, so these y, so if you look at a scatter plot, remember when you plot points you've got x, y, we're looking at this point, so if the actual point is 4, and perhaps on the line here, this might be 3, so it's going to be 4 take away 3, the predicted value which is on the line, predicted value referring to the values on this line, 4 take away 3 equals 1. So that means that space between this, where the point is of 4 and the predicted line there, is 1. There's a space of 1. The residual is 1. Okay. Now let's look at that in a table format here. Okay, I'm going to rub these out because I actually did these before. But remember, the residual is basically the difference or the space between the actual value and the predicted value, which is the line. And the actual value is plotted, so it's the dots, and the predicted value is all on the line. Okay, so let's say, for example, a line gives you the following, this. So the line is described by this formula. So this line is basically this formula. Y equals 0.634x plus 64.945. So this is an example of how you can actually calculate the residual, or the residuals, for all of these. So if you have all these plotted on a scatter plot like so, and then you drew the line, which is this, okay, what would be the space between each dot and the line? And this is how we calculate it here. This is a long way of doing it. In year 12 you do learn a quicker way of doing it, but basically what you do on your CAS, let me open this up, so let's go home, your document, no, so we'll go to calculator. So I can see that my formula, okay, it was y equals, let's make this a little bit bigger. Okay, don't need to necessarily write the formula, but I can just go 0.634x 34 times, okay, whatever my x variable is. In this case it's 18, so we'll go 18 plus 64.945. okay, when I do that, the predicted value, okay, based on the line, so if that's my line and I've used my line to actually predict a value, if x was 18, what would the predicted value be? 76.357. So let's do that to three significant figures. So 76.3, 0.4, sorry. So that's the predicted value. Okay, and for the next variable, so we'll try for if x was 19. So what I did just then is I went up, highlighted this section and pressed enter, and it repeated it for me. I'm just going to change x now to 19. So 76.99, I can just round that to 78. Okay, and then I can repeat that, go up, highlight that again, and change the x to 20 to get the next variable, 77.6. Okay, now I'm not going to go and do that because it's going to take way too long, so I've gone ahead and just done it here for you guys. There's all the predicted values. And now let's calculate the residual. So remember, residual is calculated by using that formula of the actual value of where the dots are, or the scatter plot is, take away the predicted value of what the line predicts. So basically it's just going to be these, if you look here, these are the plotted dots. It's going to be the y value, take away the predicted value on the line. So 76 minus 76.4 is negative 0.4. And then 77.1 take away 78 is negative 0.9. 78.1 take away 77.6 equals 0. What's that? No, 5. No, negative 0. Oh no, yep, that's correct. Yep, 0.5. 78.3 minus 78.6 is negative 0.3. 78.9 take away 78.8 minus 78.9 is negative 0.1, and that will equal negative 0.1. So this minus, I'm basically going this take away this. Okay, so 79.9 take away that is negative 0.3. I think it would be, yep. This one would be 81.3. That would be 0.5. So not a negative, just 0.5. This would be negative 0.3. This would be negative 0.1. This would be negative 0.1 as well. And then this would be 0.2. So there are our residuals. Okay, and you can see this makes sense because the space between the dots and the lines isn't that, the dots, so the scatter plot, and the predicted line isn't that great, which means that that line is a good predictor, okay, for that scatter plot. Okay, so let's do the same for this one. I've already gone ahead and actually done this already in my calculator. So I've got my formula there already, and I've scribbled this out because I don't think this is as relevant in year 11. It's more so in year 12 that we do what I scribbled out here, but here basically it's the same procedure where I've got my formula. Okay, got my formula, so let's get rid of all this. My formula was 26.732 multiplied by, and I can pick, I'll just go from the start. So the volume of 5 x, these are the x variables, these are your y variables. Yeah, so 5 plus 16.226. So there's my first value. I've just rounded them, by the way, to the nearest decimal. So 149.9 for that one, and then you can keep repeating and just change your x variable to the next one, or it's going to be the same. So that's the second one. Third one, so I'm looking at the third one here, 3.1. So change the x variable to 3.1. 99.09, which I rounded to 0.1, and you can keep repeating to get all of the predicted variables there. So I get rid of that. And remember, to get the residual, it's basically the actual value, take away the predicted value, and there is my residual there. Actual value, take away predicted value, and there, these are my residuals for it. Okay, get rid of that. So now sometimes you'll get a question in year 11 where it asks you to calculate the residual if you don't have a graph like that. Okay, or if you don't have a scatter plot, or neither do you have a table like this. It might be like this. So calculate, so if you've got this formula of y equals 26.732x plus 16.226, calculate the residual if the volume was 7, so if x was 7 and the number of people was 200. So this is on the plotted graph, it's 7 to 100. Okay, I want to calculate the residual if my formula was this, and what would the residual be? So using the formula, y equals 26.732x plus 16.226. Okay, so if you got that, now what you'll do is you'll predict what the value is going to be, and then you'll minus that from the actual value, which was 200. So let's make a prediction. Y equals 26.732 times x variable, which is 7, plus 16.226. So my CAS, I've already got that formula, which is great. Just change the x variable to 7. And the actual value, the predicted value is 203.35. So y equals, I'll just round it up to one decimal. So 0.35 will become 0.4. So remember, to calculate residual, it's the actual value on the scatter plot, take away the predicted value from the line. So if the actual value was 200 there, and you minus the predicted value from the line, which is the formula, minus 203.4, that would mean that the residual value for this, so for this question, it says calculate the residual value if volume was 7 and number of people was 200, would be negative 3.4. So that's the residual value. And that's how we calculate residuals.